Good morning, everyone. So, I think a lot of people are already here. Some probably still getting coffee. First of all, welcome to the second day of HHAI 2023. I hope you had a great evening yesterday in the welcome reception. I think it was a lovely building, and I hope you kind of made new friends and got to know a lot of other participants here. And now we will start with the second keynote of this conference, which is held by, wait a second, Frank van Harmelen. And he will talk about hybrid intelligence from vision to science. Now, a little bit more about our second keynote speaker. He is a professor in knowledge, representation, and reasoning at the Computer Science Department of the Vrije Universiteit in the Netherlands. He has quite some extensive work done on AI and semantic web, sorry. And has quite some extensive work on that, and recently focused a little bit more also on human in the loop, human AI, collaboration aspect. And as that, he's actually the principal investigator at the Hybrid Intelligence Center in the Netherlands, which is a collaboration of several universities focusing on the collaboration between systems and humans. And as part of that, he's also actually one of the founding members of the HHAI conference itself. And with that, I will hand it over to Frank to talk more about his vision on hybrid intelligence.
Great, thank you very much. Sound is working okay? Good, thank you. Thanks for being here in the morning. When I walked through the corridor here, I realized that this room is actually called the arena. I don't know if you know what happened in the arena in the past. Okay, so let's see what happens here this morning. When I submitted the title, I think I made a mistake. I said, well, I'm going to talk about from hybrid intelligence from vision to science, but I think I forgot one character. Oops. That was not the idea. I don't think things changed on my end. Okay. So let's see what happens. I forgot this character. Okay. It's a talk with a question, right? And the idea for this talk was triggered by an observation, namely the observation of the really unexpected quick adoption of this term hybrid intelligence. Okay, unexpected maybe not for you, but at least it was certainly unexpected for me. And I just, so these are quotes that I came across in just the last few, maybe the last year, a bit more. Why hybrid intelligence is the future of AI, McKinsey. We all know if McKinsey says it, it must be true. It's better to view AI systems not as thinking machines, but as cognitive prostheses that can help humans think better. Okay? I mean, this could have been a literal quote from the description of this conference, and this is from Deloitte, one of the big consulting companies. Collaborative intelligence, humans and AI are joining forces in the Harvard Business Review. A shift to hybrid human-computer intelligence driven ecosystem in Forbes. And Microsoft has a report out that is called Hybrid Intelligence and the Future of Work. Right? So these are big, serious opinion leaders in what is always called the real world. This is really making quite an impact, and this is really very fast. So when we were writing the grant proposal for the Dutch HI Center in 2018, this hybrid intelligence and this collaboration and this augmenting human intellect and so on, all those were kind of new, trendy buzzwords, and they've really made it into the opinion leaders now. And this is actually very fast. So the other sort of science to technology that I've been involved in is semantic web, which started out as semantic web in 1999, and it took until 2012, and which is now known as knowledge graphs and linked data, and is really widely adopted. And that took 15 years, right? And even that was considered fast. And this is only 5 years. What should we do now? Should we just retire early, right? We declare victory and we'll go home? Or what would it take to become a science, right? So to go from this vision, because to be honest, if you read those publications from the Harvard Business Review and Forbes and Deloitte, I mean, there's not a lot of science in those. So what would it take to become a science? Okay. So that's an intellectual challenge, but there's also a really hard-nosed self-preservation reason to think about science and to become a science. And the reason to think about that is the shape of this curve, okay, which you all know. That is the Gartner hype cycle, and human-centered AI is here, okay? So it's great that we're on the curve, right? And we're still on the up, but we all know what's going to happen very soon. And this is the fate of. If we want to avoid this fate, right? One way of avoiding this fate is to actually turn ourselves into a solid discipline, rather than a vision that makes it to Forbes and the Harvard Business Review, because then you end up here. The only way to end up there is to turn yourself into a solid field of investigation. So that's the mission, the goal for today. That was the observation that led to the idea for this talk. I always tell my PhD students, and actually I've told it to one or two people at the doctoral consortium, which was really fun on Tuesday. I always tell them, don't start your talk with an apology, right? No, don't do it. You just put yourself on the back foot, okay? So what am I going to do? I'm going to start my talk with an apology. So what's the apology? So this is a bit of a pretentious talk, right? So it's a bit of a philosophizing talk, right? So this is me, in my armchair with my pipe, smoking my pipe and doing methodological observations, right? And Janine, you can testify for this. I was actually a reluctant keynote speaker, right? So I said, yeah, Frank, it would be great if you gave a talk about this. And I think in the end, Stefan leaned so hard on me because I thought it was really difficult to do this. So I'm not very sure about what I'm going to say, right? So this is not your typical keynote where the keynote is standing on the stage and is telling what the world looks like according to their research. I'm asking, I'm not telling, right? And I'm searching. I don't have all the answers. Remember the question mark at the end of the title? So join me in this sort of search, right? Instead of expecting answers. If you're lucky, you get good questions. And this has been tried before. Right, so I'm not the first one to try this. Actually, this is the 4th attempt at this. So I see John with a big grin on his face at the back there. So we organized, this is almost exactly a year ago, when a bunch of us went to Darkstool and half of us came back with COVID, including John and me. And the title of that Darkstool seminar, which is a German castle in the middle of nowhere where you get locked up to talk about a theme with colleagues, the theme was a research agenda for hybrid intelligence. And it was a really difficult thing to do. We were a very diverse group of people. I think quite a few of us in the room were also there. So it was a very diverse group of people. We came from very different backgrounds, we had different opinions. We all felt the need for this agenda. And we made progress, but I don't think we got there. And then John gave a talk in Stockholm at the meeting of the Human-Centered AI network, also in an attempt to kind of make sense out of what we had done in Darkstool and move it a little bit further. Then we had a writing session with John and Frank and Virginia Dignam and myself. That was around February, I think. And again, we made some progress, but we didn't manage to actually produce the white paper that we were hoping for. So these were all brave attempts, and this is just attempt number 4. Okay, so as a community, we are trying to do this and moving this forward. Right. So if you want to know who you are or who somebody is, then it makes sense to ask who their parents were. And I think these are the three of our main parents that I will be considering in the talk. Right. So we are somehow, there are people here from AI, there are people here from HCI. I'm not sure if there are many people here from psychology. Okay, good, great. Because we need you, because I'm only an expert in one of those, right? I'm an AI researcher. So I'm going to say stuff about HCI and psychology, but now correct me if I'm wrong, and okay, so help me out there. So let's start with a working definition. So actually, I was thinking hard about whether I should do this. Because I think there is a bit of a fallacy often that people say, well, we can't discuss this because we don't have a definition yet, right? I think that is just wrong. I think definitions are not the start of a discussion. Definitions are the outcome of a discussion, right? If the biologists would never have done biology before they could agree on what the meaning of life is, then we would never have done biology. They figure it out along the way, right? So the definition is the outcome, not the beginning. So don't get too hung up about this. But this is a phrase that I've heard in the past few days, and you see it also on website of the Dutch Hybrid Intelligence Center and the recently started Finnish center. I've seen you in the room. So yeah, great. So now, hybrid intelligence as the combination of human and machine intelligence, augmenting human intellect and capabilities in order to achieve goals that are unreachable by either of them separately. Okay? So we could quibble about some of these words here. Is it intellect or something more? Is it augmenting or something else? But this is the general idea. There's also an interesting a report from last year by people from Stanford and the Rockefeller Center, where they make the following observation. They say, well, if you now look at two of the dominant parts of the debate on AI, there are about AI systems. Now, that's what the AI scientists do. They build and investigate systems. Or it's about AI regulations, right? And it's the discussions about trust and responsibility and the regulations in the AI Act. There was an entire workshop about this. But in both of those discussions, the unit of analysis is the AI system, right? It's about regulating, it's about building the AI system, or it's about regulating the AI system. Whereas I think the crucial difference in hybrid intelligence is that the unit of analysis is the human-machine system. Right? And I think that's a really important difference. Okay. But this is not uncontroversial. Okay? Ben Schneiderman, who is, I think, maybe the eminence grise from HCI, he has a personal newsletter. I think young people now call it a blog. And he wrote this a few months ago. Right? He said, because he had spotted this conference. I guess people he knows go to this conference. So and I want to read this out to you because it's really interesting. He says, while the goal of amplifying instead of replacing human intelligence is central to my thinking about what defines human-computer AI interaction, I hold an extreme view, preferring to ensure human control of super tools and telebots rather than having AI systems cooperate. Right? So he doesn't like the phrase cooperate. Right? With people or participate in hybrid systems. Okay? He also doesn't like the word hybrid. Right? For me, people are a different category from machines because humans are legally and morally responsible for the use of technologies. And now he makes this personal. He says, I encourage participation in this conference, but I hope that the organizers, right, and there you are, Janine, John, Ilaria, right, I hope, and the attendees will clarify their position and strengthen the theme of amplifying and ensuring human control. It may be too much to ask, but I hope that the conference name might be changed to something like Amplifying Human Intelligence with AI. Okay, so this is, we had a big debate about this in our lab, and I think the idea here is that he would like to, let me take my gloves off. He is stuck in the vision of the hammer, right? A computer system is a hammer in the hands of a user, and the hammer doesn't do anything until the user tells it to do something. Right? The hammer is a passive tool. There's no agency in the hammer. Okay? And I think the crucial idea, one of the crucial ideas, is the agency of the system. So and this is truly controversial. Right. So that is a very interesting phenomenon. Right. I have no idea what's going on. Maybe every time you stand up, it gets fixed. So then let's, no. Oh no. We practiced this before. I think the cable is a bit dodgy. So now what does it take to be a science? So this is going to be the travel guide for the rest of the talk, right? What does it take to be a science? Well, as a science, you need shared assumptions. Okay, so you need to agree on something before you can even start having the conversation. If you don't share a set of basic assumptions, you can't even have a meaningful conversation. So what are those assumptions that we share? Then you need, of course, you need a shared language. Otherwise, you can't communicate and collaborate. You need some agreement on what are the important questions. Right? We don't need to all work on the same question, but we need some agreement on what are the important questions in the field. What are the methods that we then use to investigate those questions? What are the metrics that we use to measure our progress? Right? And what are the kind of results that we are aiming for? Right? Clearly, we don't know the results, but we would like to know what kind of results we're aiming for. Okay, so I mean, this is not new. You would read this in any textbook about what it takes to be a science. So this is what we're going to travel past these 6 points. Okay, so let's start with assumptions. Okay. Just to clarify, so what do I mean by these assumptions? I took a field which has 500 years of history. Okay, so I took physics. So what would be the assumptions that they make? Okay, well, here are the assumptions that physicists make. Right? So they assume regularity, namely they assume that the universe follows laws, okay? And that these laws, that's the point that we're going to investigate in physics, right? And they assume that these laws are invariant across time and space. So the matter of the way things work in another solar system or in another Milky Way is not different from ours, right? The laws are the same. And these laws are independent from the observer. The universe is not a subjective experience. It's not like, well, my universe looks like this and yours looks like that. No, we share our observation. The observations are independent of the observer. And there is causality. Events are causally connected. Okay? Now, these may all sound completely obvious, right? But they're not. Right? So you could believe in the existence of a flying spaghetti monster, and the flying spaghetti monster interferes in the physical universe according to its whim, right? And it changes the way things go in the universe. Okay? Well, then there wouldn't be such laws, right? And even sort of objectivity is also, of course, disputed, right? So these are non-trivial assumptions, but these are the ones you need to agree on in order to be part of the physics conversation. And you don't need to agree on them, but then it's really hard to be a physicist. Okay, at least we've now found the cause of the problem. Right, so what would those be for HI? Okay, so this is now me putting my head on the block, and it's up for you to chop it off. That's why this is called the arena. So I think we inherit some of these assumptions from our parent fields. Okay? So from AI, we inherit the assumption that intelligence is computational. Right? That it makes sense to talk about intelligence as something that can be computed. Right? And there's a lot more to say about this, and my colleagues made me take out slides from this presentation because they thought we would just get hung up on that. But intelligence is computation is one assumption. We also assume that systems have agency. Right? That systems, they can be active and proactive. We are no longer in the hammer scenario, where if the hammer lies on the table, nobody touches it, the hammer doesn't do anything. Okay? And we assume that individual agents act rationally. And this is rationally in the economic sense. Right? So not logical, but rational in the sense of they have a goal and their behavior is intended to achieve those goals. Okay, that's the economic sense of rationality. And Andre yesterday pointed out to me that it's the individual agents that act rationally. Right? So it could well be that a group of agents end up as a group, they get stuck in some local minimum, and together they don't act rationally. So none of them achieves their goal, although each of them were out to achieve the goal. That's also something we need to be aware of, that the human AI system may end up in a non-rational local minimum, even though both the human and the AI were out to achieve their goals. From psychology, we inherit assumptions like human behavior can be predicted, right? That just like other branch of physics, or other branch of science like physics, human behavior is also subject to laws. And we can understand those laws and we can use those laws. And the view that humans are, among other things, information processors, right? So we can understand human behavior, at least parts of it, by thinking about humans as information processors. And from HCI, we inherit the insight, the assumption that humans and AI systems have different and complementary strengths and weaknesses. Right? That's in a way one of the reasons why we are here, and that this relation is asymmetric. Right? So I think maybe that's where Ben Shneiderman's itch comes from, that when he sees cooperate or collaborate, that for him that implies a symmetrical relationship. Now, Wendy Mackay at the Doctoral Consortium, she has this rider and the horse, or Catalijn has the owner and their dog. Right? So this is a cooperating system, but it's clearly an asymmetric system. So these would be sort of my proposals for some of the assumptions that we share here in the room and when we collaborate on our work. And discuss, right? Okay, so let's leave that for now. Then, of course, we need a shared language, right? So there I've only done an empirical exercise, right? Just word mining. So we inherit a shared language also from our parents. We all come from our different fields. None of us went to grad school and did an MSc in hybrid intelligence, right? We all did an MSc in one of these or something else. So we inherit those languages, right? So these are the terms that you would use to speak about AI, right? Learning, reasoning, systems, machines, to develop stuff, software, knowledge, computation. That's the kind of AI vocabulary, which is very different from an HCI vocabulary, right? Which is all about skills and actions and manipulation and learning and gestures and inputs and so on, right? And that's, again, very different from the psychological vocabulary, right? So actually, this is I found a paper where they text mined 50,000 psychology papers and just did a word count, okay? And these are the top 50 or so words, right? So things like analyze, participate, it's about tasks and processes and the significance of effects and so on, right? And I also took the research agenda paper that we published in 2019. This was maybe attempt number 0 at this game. So here are the words that were there. And here you already see a happy mixture of all of the previous ones. Right? So there are some psychology words here, there are some HCI words here, there are some AI words there, right? And you all know this picture, the "we need you." This picture is carefully designed so that this finger points at you, right? If you're there, you think this finger is pointing at you, and if you're there, you think this finger, okay, and it is, right? So this finger is pointing at all of us, right? So we need to develop this language. We can't just keep speaking all our own dialect. Again, it's fine, we all come from a different planet, so we all bring our different languages, but we need to somehow develop a shared language, okay? And by the way, a shared language is not just a list of words, okay? A language is much more than a list of words. So therefore, I think it's very exciting work that Ilaria and Victor and Stefan are doing at VU, about developing. So this is a part of their as yet unpublished paper. This has been unpublished for way too long, guys. So this is a hierarchy of tasks, right? So these are task words, right? Tasks like prediction and reasoning and acting, with classes of tasks and subclasses of tasks. And so this is a vocabulary not just as a list, but with a structure, in fact, a hierarchical structure, right? And now we could argue about whether they got it right or wrong. That's not my point here. My point here is we should be doing this kind of stuff, right? So to bring some structure into the list of words. Here's another example of what they do, right? So these are words with relationships between them, right? And then they go on later in their as yet unpublished paper to take a few example scenarios and analyze them in terms of these structures. So I think that's exactly the kind of work that we should be doing. Okay, so that's about language, right? The next thing is that we need a shared set of questions, right? So we need to recognize the importance of each other's questions. And even if I sit here and I listen to a paper, I mean, yesterday there was not a single paper about the topics that I'm working on, right? But I could see the relevance of all of them, to the topics of the conference. And I learned from many of them. Right? So what I did here is I did a text mining exercise again. I went to the website of the Dutch Hybrid Intelligence Conference Center and the IEEE paper we wrote. I went to the Hybrid Intelligence Center in Denmark. I went to the website of the brand new Hybrid Intelligence Center in Finland. And I looked at the Stanford Rockefeller paper and just basically tried to extract the questions that they're asking. Right? They propose that we should be investigating. Sometimes this is actually surprisingly hard work. You would expect that the question is a sentence that begins with a capital letter and ends with a question mark, right? But often there's like, very woolly paragraphs, and then you have to figure out what is actually the question that they're asking. But so that's what I did. And then, so here are just some examples. So let's just go through them. So how to achieve mutual and situational awareness, right? Of goals, the goals in the hybrid team, the weaknesses of the other partners, the situations that the team finds itself in, the hybrid team finds itself in, right? And here you could think of things like shared mental models, right? If I collaborate with somebody, then, or even if I have a conversation, we need somehow a partially shared mental model about the topic of interest, right? If we don't have a shared conceptualization, it's very hard to have a conversation. So that's the shared model of the world. But there's also a model about each other, which is a different thing, right? So the theory of mind. This is, okay, I have somehow a model of what my collaborators know and don't know and want and so on. Okay. Now we humans are intensely multimodal, right? So I move all the time and I move my hands and you see my face. So our machine collaborators will need to be able to process these multimodal signals and also produce them. And so I think the work of Anna Paiva yesterday in the keynote was a great example of that. Her robots really use these multimodal social signals. Okay? How to adapt to changes in the environment. So our AI systems are extremely bad at this, right? So we program a system or a system learns something and then we let it go and do its business. But it's pretty much frozen in time at that point. Of course, there are exceptions to this, blah, 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 but the mainstream thinking is like that. And we need much more work on things like active learning, online learning, incremental learning. And of course, all these things exist, but they are barely mainstream. Okay? So how to agree on goals and task divisions. And if you're in a team, you need to somehow allocate or negotiate the tasks. And how can HI systems explain, but I don't think it's only about explaining. It's also about justifying, which is not explaining how you got to the answer, but it's about justifying why the answer is reasonable. And the reason why the answer is reasonable might be completely different from how you actually got to the answer, right? So explain, justify, and persuade, right? And I think we need to do that in two directions. So not just the machine needs to persuade us, but sometimes we will need to persuade the machine, right, to do certain things or certain things in certain ways and so on. So I think that's a bidirectional communication. Okay, so those are just 5. Let me do a few more. So this is the cluster about responsible and ethical behavior, which is you could clearly recognize also in the program of the workshops. How to build AI systems that behave ethically, methods for reasoning about, so ethical reasoning about HI systems and ethical reasoning by HI systems. So in the first, you're sort of doing software engineering style, how can we make sure that those systems behave ethically? And the other one is you're developing algorithms that take ethical behavior into account inside the system. Right? And what are appropriate legal frameworks? Because most of our legal frameworks, we have lots of legal frameworks to regulate technology, but they're always in the hammer frame of mind. Your car doesn't move until you move it, okay? And that's true for pretty much all of our technology, but we are now with hybrid intelligence, we have these systems that have agency, and that really calls for new legal frameworks. We like our system to be safe, but we also like them to be adaptive. Well, that's bad news because it's hard to have both, right? Because if they are adaptive, then it's much harder to ensure safety. And of course, these are just 10 of the questions that I extracted, and of course there are many, many more. Well, I hope that I've seen some of you nodding. It's very helpful if your audience is nodding sometime, okay? That's, especially if you don't know whether what you say makes total sense, then, so help me out. So I've seen some of you nodding when I was going through these questions. Well, that's great. But now we need to agree on methods that we will use to investigate these questions, right? Because I only believe your answers if I can understand the methods, how you got to the answer. And of course, we can do nothing but inherit those methods from our parents, right? So here are the three parents again. What does AI do? This is oversimplification, but a major method in AI is in silico experiments. And of course, now we also do compositional design, and we do real-world experiments, but you know, a major thing in AI is in silico. You run computational experiments, right? The program never leaves the computer. In psychology, they do controlled lab experiments, right? They take typically a population of first-year psychology students, and they lock them up in a lab, and they make them do silly tasks, right? Like eye tracking and looking at the dot, and so very controlled lab experiments, right? And in HCI, I think they are very keen on what they call ecologically valid, or what other people call real-world experiments. So you try to put the user in as realistic a situation as possible, and you try to see what you learn from that. So these are very different methodological approaches. I'm trying to wiggle the cable. I see. The cable has now definitively decided not to talk back anymore. It's not this one because it's glued. Yeah, okay. Okay, and the plan is to do this, and then I no longer need to touch it. Good thinking. Yes, thank you. So, most of us will be familiar with one of these three, right? So we really need to understand each other's research methods, right? And again, okay, this is only where we start. Right? I would be surprised if it stays that way. So maybe we will need to develop new methods or new types of methods that we will have to develop in this community. Okay, metrics. So, as a scientist, you need to be honest, right? You need to be critical. You need to be able to measure your progress, right? When you write a project proposal, you should write how you're going to measure your progress. This is informally known as the rope by which you are later going to hang yourself, right? And you need to be explicit about that, right? Maybe the flying spaghetti monster doesn't want me to give this talk. Okay, let's do the trick again. No, so it's really the hardware. No, but it's the cable. So it's not it's the cable that plugs into the laptop. That's the problem. Okay, so where were we? These metrics, right? So what are the metrics that we inherit from our parents, right? So AI, the dominant method, at least currently, is performance on a benchmark, right? In some communities, it is the ability to prove a theorem, okay? But That's no longer the dominant mode of thinking in AI currently is performance on an artificial benchmark. In psychology, it is the predictive power of the theory, right? So you have a bunch of variables, some of them are the dependent variables, some of them are the independent variables. Now, can you predict the relationship between those based on your experiments? And in HCI, it is how happy or how effective is the user in a certain setting using a certain setup, a certain interface. And again, each of these will be new to different parts of the community. Right? Since I'm from AI, let me give you one warning about this metric in AI, okay? So the warning is, be aware of the curse of the benchmark, right? So we now read papers that look like this, okay? This is just depressing, right? So this is a whole bunch of systems, and this is a whole bunch of data sets, and this is a whole bunch of metrics for each of the data sets, and then this is currently the theory we have about AI, okay? So this is really bad. Why is this bad? Not only because it doesn't give a lot of insight, but it freezes the community, right? So it encourages, the curse of the benchmark is that it freezes the community in doing gradient descent, right? We're all optimizing for the benchmark, right? So the community is somewhere here, and then everybody is doing a gradient descent towards the local maximum, and the local maximum is defined by the benchmark, right? So we do these micro innovations, right? And the benchmark might well be a local maximum, right? Well, we defined the benchmark when we didn't know what we were talking about in the field, right? So we are all optimizing for a local benchmark, and nobody dares to do a big jump in the search space, right? Like to jump to a different part and maybe we end up on a better maximum. Because if you do a jump in the search space, the first thing that happens is that your performance on the old benchmark drops and you no longer get your papers published, okay? Benchmarks are great, but you can be a little bit too much attached to them. Okay, so that brings us to the last. So what are the kind of results that we are looking at, right? What are the kind of results that we're looking at? Well, if you look at the other sciences, so what are the results from physics, for example, right? So the results from physics are not, well, the circumference of the Earth is 40,000 kilometers, right? I mean, that's, or the distance, it takes 8 minutes from the light of the sun to travel to the Earth. It's all true, but those are sort of factoids, right? There's a trivia. Those are not the real results of physics. The real results of physics are principles, right? Generic principles that these laws that we assume to be immutable and present. So now, for example, these are examples from the principles from physics. Things like, you've all learned them at high school: conservation of energy, increase of entropy, the constant speed of light, the quantization of energy. Okay? Those are the real principles, the real results of physics. And actually, we also have this is my attempt at thinking about this for AI, right? So in AI, we've learned, problem solving is search in state space, right? And we have lots of search methods, and these search methods are then a way of solving a problem, okay? And machine learning is a search in function space, right? So you're exploring a space of functions, trying to find a function that best maps your inputs to desired outputs. And we can achieve rationality. Rationality is achieved through this perceive, plan, act loop. Okay? So those are just some examples of, okay, if you nail me to a chair and torture me enough to give the principles of AI, this is what I would come up with. Okay? So, well, what would be the principles that we would come up with? Okay? Well, why do you think you are here, right? So clearly I'm not going to give you that answer because I don't know them. Right? Again, this is all of our work to think of these. Right? We have, I think, some foggy picture of where those principles will end up. Right? And these are literally taken from the resulting report from the Dagstoel meeting. Principles around collaboration and communication. Principles around adaptivity and control. And the tension between these two. Principles about responsibility, principles about explainability and transparency. Right? And nicely enough, these make a very nice acronym. Okay? So this would be my guess of where those principles, where they would end up. But of course, I don't know what they are. So that concludes the journey. Right? So now we've done all of those, and I've put my head on the block on some of them, and this is, I think, what we need to be doing. So, of course, let's not retire early, right? Let's make it a science by doing those things. And now what do we do now? Okay, you can go home and think, well, that was nice. Let's go back to the usual stuff at home. Now, so I also wanted to give you some homework. So after all of this philosophizing, what do we do now when we go home? The first is get to work, right? Work on those questions. Work on the questions in my list of 10 or in your list of 20. So work on those questions using the methods and the metrics that I put forward or that we will agree on in the future, right? This was just my proposal, so just get to work. Second, stay together, okay? So this conference is really crucial because we're not going to get to hybrid intelligence by just doing AI or by just doing HCI or by just doing psychology, right? So this conference is really one of the places where we can meet to do this. So this is not optional. Make sure that you're there next year, okay? The other thing you should do is experiment, right? And remember that every system is an experiment, right? A system is not your result, right? Your result is whether or not your experiment confirmed the hypothesis or not, right? And Anna Paiva's talk, she's not here, so I can freely compliment her. Anna's talk yesterday was a great example of that. She built these really uber cool systems, these card-playing robots, and it was all really great. But they weren't just there for the sake of them, or because she thought card-playing robots were such a great contribution to society or to our economy. She built them to test the hypothesis, namely hypotheses about team formation and hypotheses about the importance of multimodal signals in collaboration between humans and machines. Right? So, do the engineering, build the systems, but remember that every system is an experiment. And don't be afraid to theorize. Right? So we need to do a little bit of what in the end Janine and Stefan forced me to do this morning, is do a little bit of theorizing about our field. Right? Try to build an ontology of different types of hybrid intelligent collaborations. Right? What would be a typology of different types of collaborations? And think explicitly about new experimental practices or new metrics to measure our proposal. So don't be afraid to philosophize, theorize once every while. And finally, challenge each other. Right? So, and by that I mean that we should translate results from one field into a challenge for another. So let me give you some examples. So for example, in HCI, they talk a lot about adaptive interfaces. Right? So the interface adapts to the properties of the user or the situation, right? So of course, this requires learning. The machine should learn from the behavior of the user, right? And then adapt itself. That's called online learning. Well, good luck with that in most AI methods. And it's learning from small data, because you don't get 10 million interactions before the interface adapts. This should adapt after interaction number 3, okay? So that's a challenge from HCI, we want adaptive interfaces, to AI. We need different machine learning approaches. And I think there was a really nice talk yesterday about this relabeling training data for image recognition during task execution. I think that was a really great example. Another example challenge would be, okay, in psychology, they know a lot about the variables that influence human-human collaboration. Okay? Now let's challenge the psychologists, say now do it now, but for human and machine collaboration. Don't lock up 2 psychology students. Lock up in your lab, lock up a psychology student with a machine and see what the variables are that drive that collaboration. So do those challenges between each other. That's it. Thank you very much.